Okay, so today is the topic for notes, comparing distributions. Before we compare distributions, we are going to review the last 2 days worth of notes. So here's data for GPAs for Mrs. Davies' 6th hour from last year, okay? So we're gonna put this data into a box plot. In order to make a box plot, we need to type our data into a list and get our 5-number summary. Who can remind me, how do I get to a list? Stat. Perfect, go ahead, type your data into a list. Okay, so then you go to stat, arrow over to calc, and number one variable stats. Scroll all the way down, that brings up your 5-number summary. So for the minimum, hopefully you got 1.2, quartile 1, 2.45, median 3, quartile 3, 3.2, and our max was 3.9. Okay, now in order to make the box plot, you need to check for outliers. So let's do that off to the side. I'm going to rewrite my outlier formulas. Outliers in the lower direction are less than Q1 minus 1.5 times IQR. Outliers in the upper direction are greater than Q3 plus 1.5 times IQR. Bless you. Okay, go ahead. Type in the information you have. Who can remind me, what's the formula for IQR? Just say it if you know. Good job. Q3 minus Q1. So what is the IQR here? What number? Well, it's Q3 minus Q1. 1.45. Lower than 1.45. 0.75. Because you're doing Q3, which is 3.2, minus 2.45. Go ahead. Determine if there's any outliers. Okay, outliers in the lower direction. Hopefully you got less than 1.325. Anyone agree with that? Okay, are there any outliers in the lower direction? Is there any number that's less than 1.325? Yep, there is. So, yes. Is it just 1.2? I think so. Now, the upper direction. Outliers in the upper direction greater than, what'd you get? Perfect. 4.325. Your max is 3.9, so there's no outliers in the upper direction. Questions on how I did that? Okay, so now we're going to make the box plot, which means we need a number line. Go ahead, use your ruler, draw yourself a number line. So the minimum's 1.2, maximum's 3.9. I'm going to start at 1, you guys, and I'm just going to go by increments of 0.2. But you can go by whatever you want. You can go by 0.5. You can go by whatever you want. Then plot all 5 numbers from your 5-number summary. Try and go in a straight line. Try your best. Okay, but don't connect anything yet. Now, remember the 1.2 in the lower direction's an outlier. So leave that alone from right now, and let's just make the upper whisker and the box. Okay, so that lower whisker is going to go to the lowest non-outlier value in the data set. Look at your data set above. What's your lowest non-outlier value? 1.6. Okay, so that's my low. You don't. It's up to you if you want to write this down. You might want to for the sake of notes. Lowest non-outlier value. Okay, so you're going to 1.6. And that is your lower whisker, since the dot for the outlier at 1.2 needs to be marked separately. Make sure we put a label on the number line. Make sure we put a title. And I think I'm just going to use this right here for my title. So what's also a review of yesterday, you guys, is describe the distributions. Remember, anytime we see describe the distribution, that means shape, outlier, center, and spread. So here we go. Shape of a box plot. Remember, we have three choices for shape of a box plot: skewed left, skewed right, and symmetric. Take a look. You don't have to draw the line, but that's like the left side, because we look at our shape without our outlier. And this is the right. What do you think? I'm thinking skewed left. Okay, so I'm going to put shape and outlier in one sentence. The graph of GPAs appears to be skewed left with one outlier at 1.2. That's the S and the O. C stands for center. I already have a center written up here. What statistic do I already have written for center? Median. So I'm going to use that. And then what statistic do I already have written for spread? IQR. Okay? But keep in mind, you guys, you can use the mean or the median for center. You do not need to write both. What's the mean for one variable stats on my calculator? Yeah, it's the 2.785. It's X bar. So you can write mean or median for center. You can write range or IQR for spread. It doesn't matter, and you don't need to write both. Just write one, okay? But tell me what statistic you're using. So the center can be described with the median GPA of 3. And the spread can be described using the IQR of 0.75. So today's notes are slightly different because now we're comparing distribution. So now we're not just talking about one set of data, we're comparing two sets of data. You guys, when you compare data, you don't want to just give exact statistics. You don't just want to spit out statistics. You want to compare them. So if I'm talking about the last test, rather than saying 6th hour's average on the last test was an 84% and 3rd hour's average was an 81%, I'd make a comparison statement. 6th hour had a higher average compared to 3rd hour. So for this one, if you're reading this example, which is better when asked to compare? Distribution A has a higher median than distribution B, so typically students there scored better, or distribution A has a median of 83 and distribution B has a median of 64. A. Make comparison statements. Read the next one quietly and think, A or B? Which one? A. Okay. We're going to make comparison statements. Okay. Here we go. So it has, here we have the graphs of American League run scores versus National League. If you can't read, American League's boxplot is up top. I'll write AL and National League. It says compare the distributions. Okay, so I'm going to kind of jot down my thoughts before I put it into two sentences. Compare distributions. Again, think socks. Shape, outlier, center, and spread. Okay, here we go. Shape. American League. Left side. Right side. I had someone earlier today that was pretty stuck on the fact that is skewed left. The left side of the graph is a little bit more spread out than the right. Maybe a little bit more. I'm thinking it's pretty close, so I said approximately symmetric. So if you want to say skewed left for AL, that's fine. I feel like they're very close, so I'm going approximately symmetric. Okay? What about National League? Symmetric. Okay, so I'm going to jot down that note. Outliers, right away with box plots. Box plots are great for identifying outliers because they have to be marked separately. Do you see anything marked separately here? Do you see anything marked separately here? Nope. So none for both. Center. Remember, the median is marked in a box plot. So just look at the line for the median. Here's your line for the median for American League. Here's your line for the median for National League. Which one is shifted farther up on the number line? American League. So American League has the higher median. Now, for the spread, you can compare the length of the box, which would just be this piece. This is your IQR. The length of the box is your IQR. Who's got a larger IQR? AL or NL? AL. Okay. Or you could have looked at the length of the entire plot. What statistic is the length of the entire plot? What statistic is max minus min? Range. So, or you could have looked at the length of the entire plot, which is the range. Okay, so we're going to weave that into two sentences. The distribution of runs scored is, or both distributions for runs scored are approximately symmetric with no outliers. So both distributions for runs scored are approximately symmetric with no outliers. The American League has both a higher median and a higher IQR. Okay, last one. We're comparing the results of the distances traveled in cooler weather versus warmer so cold footballs and warmer footballs. So we have histograms here. Again, it says compare these distributions. So I'm just going to jot down some notes for shape, outlier, center, and spread before I put it together. Shape. What do you think? What do you think for the shape of cold footballs? Uniform. And what about warm?
Bimodal.
Good, bimodal. Awesome. Okay, so histogram for outliers. The thing with the histogram is, you guys, we don't have all the exact data points. So if there's outliers in a histogram, what do you think you would see? Spaces. Okay, spaces, gaps. Do you see any spaces or gaps in either of these histograms? Nope. So I'm thinking no outliers for either one. For center, you're looking at which histogram is shifted farther up on the number line. Okay, so that's more or less looking more at your median. Okay, so which histogram is shifted farther up towards the higher values on the number line? Warm. Okay, now the last S stands for spread. With histograms, I think it's easiest just to deal with the range. The range for cold footballs. Follow it down. Look at your maximum. Follow it all the way down. The maximum value for warm is 60. Look at your minimum for, or I'm sorry, this is for cold. My apologies. Follow this one down for cold. What's the minimum for cold? 52 for a range of 8. Go ahead, find the range of warm. What'd you get for warm?
10.
I did not get 10. 63, and this number is between 54 and 56, so what number is that?
9.
Did not get 9. Got 8? So it looks like we have the same range for both. Okay, almost done. I think I'm going to need 3 sentences for this one. Sorry, guys. Okay. The distribution for distances for cold footballs is uniform. However, for warm is bimodal. The distribution of distances, because they're talking about how far the football's kicked, for cold footballs is uniform. However, for warm footballs, is bimodal. Neither distribution appears to have any outliers. And the warm footballs have a higher median, however, both graphs have the same range. Okay. And that's topic 4.